Okay, section 1.2 is called the unit circle. Let's dive right in. So, the unit circle, what is it? Well, it's a circle, of course, and other than it being a circle that we're going to think of as being drawn on the xy plane, so centered on the xy plane, what else is there to know about the unit circle? Well, basically its radius. So if you had to guess, the unit circle is a circle with a radius of what? What would you guess? It's the length of the radius. 1. So that's it. So a unit circle is on the xy plane drawn, and its radius is 1. Okay? And as always, really quick, I'm going to go through this pretty quickly and fluidly, and if you need to pause the video to get everything written down, right, then you might have to do that from time to time. Anyway, so moving on. So again, like this is the xy plane, and this point right here has coordinates. So seeing as the radius is 1, what would the coordinates be of that point right there? Which I guess, you know, the angle that would correspond to it is 90 degrees. But anyway, the coordinates would be 0, 1. Since the length of this line segment is 1. Likewise, what would be the coordinates of this point? Well, that would make, with the radius being 1, that would make those coordinates -1, 0. And it would make these coordinates 0, -1 for the point right here. You know, that would correspond with what, 270 degrees? And the coordinates here would be 1, 0. All right? Okay, this is a big moment. We're officially going to start learning about the 6 trigonometric functions that we have out there, okay? So the sine of theta is a function. You know, the cosine of theta is a function. Tangent of theta. And then over here, the other 3, cotangent of theta, or x, right? And, you know, as long as I'm using the word function here a lot, maybe using x would be a little more orthodox or whatever, or conventional. Again, normally with functions we have x as your input and y as your output. So this could easily say sine of x, cosine of x, tangent of x, or whatever. But it is an angle, okay? The input of the sine function, cosine function, tangent, cotangent function, secant function, cosecant function. The input is an angle, okay? So theta is definitely, you know, no surprise to use it. So, so what is the sine function all about? Like, what does it do, right? If you input an angle into the sine function, what does the sine function do? Well, it's going to be equal to this, y over r. Y over r, you know, which, to be more specific, you know, based on the angle you're inputting in, right, it'd be like the y coordinate or a y coordinate corresponding with that angle divided by the corresponding radius. Okay? Let's see the rest of them. Cosine of theta is going to be x over r, right? An x coordinate corresponding to that angle divided by the corresponding radius. Tangent, what could the tangent be? It's y over x. Okay? Y over x. And the rest of them, cotangent's going to be x over y, secant's going to be r over x, cosecant is going to be r over y. So pause the video if you need to finish writing those down, because moving on with a question for you. Do you notice anything about, well, I'll even give you a little bit of a help. These 3 compared to these 3. What do you notice as a comparison? Well, there might be a lot of things that you notice, I don't know, but the thing that I want to point out is that the cotangent is merely the tangent flipped. And the official word for that, technical word, is reciprocal, or as I say, refliprical. So cotangent is just when you flip the tangent. Secant is just the flip of cosine, and cosecant is just the flip of sine, right? Moving on. Now that is something that it's definitely going to matter going forward. You know, the fact that we have like reciprocal relationships, that is no small thing, right? It's very, very, very deliberate and it's big that I want. It's a big thing I want to point out. Okay, as we move forward. All right, already kind of like an example problem that could be thrown your way, right? Well, the situation is we have the unit circle, right? Which I guess should technically be included in whatever directions there are here. You know, the directions here would say, find the sine of theta, the cosine of theta, the tangent of theta. Find all 6 trig functions of theta. And also the direction should pretty much say, and by the way, this circle you see before you is in fact the unit circle, and you know, which means the radius is 1. And theta, by the way, you know, is right there, I guess. But that doesn't matter so much as, you know, the fact that r equals 1. And what does x equal, right? Well, x coordinate, y coordinate. So not a big secret. X is root 3 over 2. Y is 1/2. And now, since we know that, x, y, and r, what else do you need to know in order to figure out the sine of theta, the cosine of theta, and so on? So going off of our definitions, the sine of theta is y over r. Y divided by r. So that would be 1/2 divided by 1, which of course simplifies to 1/2. The cosine of theta is defined as x over r. And what is our x value, or x coordinate? Root 3 over 2 divided by a radius of 1, which that simplifies to just root 3 over 2. How about the tangent, which is y over x? So that's going to be my y value divided by my x value. Okay, so what do we have here? How are we going to work with this? I'm not going to leave this as my final answer. How do I do 1/2 divided by root 3 over 2? It's a fraction divided by a fraction. And I guess the bottom line is, or the big question is, how do I divide by a fraction? Well, I guess you should know this. In order to divide by a fraction, you would multiply by its reciprocal. So this can be rewritten as 1/2 times 2 over root 3. And I see how the 2 and the 2 are going to cancel out in a manner of speaking. And the bottom, the final answer for tangent of theta is going to be 1 over root 3. Quick reminder how I don't need you to rationalize the denominator. I don't need you to fix it up and simplify it further. You can leave it as 1 over root 3. So, now we move on to cotangent. Well, people, could I start from scratch and use the formula or whatever, the definition as x over y? Yes, but I mean, right from early on here. What did I say here? I said that the cotangent is just the refliprical of tangent. Well, guess what? That doesn't just mean I can remember the definition. If I know that the tangent is 1 over root 3, what do you think the cotangent's going to be? Like the final answer of cotangent, guess what? It's going to be the reciprocal of this. So root 3 over 1, which of course just is root 3. The secant, do you remember what the secant was the reciprocal of? Cosine, which means I can just take this final answer and flip it. And that's final answer, just like that. And cosecant is the reciprocal of sine, and I can just work with the final answer, of course, which is at the end of the day, final answer is just going to be 2. So once again, before we move on, that is a very useful trick or piece of information to remember that'll help you. I guess the bottom line is here is if you know sine, cosine, and tangent already, like you did all the work or whatever, and you have the answers for sine, cosine, tangent, you can just flip to get very quickly your final final answers for cotangent, secant, and cosecant. Next example, next question here is, what is the sine of pi over 2? Pi over 2, if you remember that pi is 180 in degrees, that would make the sine of pi over 2 equivalent to saying the sine of 90 degrees. So what is the sine of 90 degrees? Well, if you remember, we know the sine is defined as a y-coordinate divided by the radius. Okay? So we need an r value, and we're going to be using the unit circle here, so it's going to be an r value of 1. But what is the y-coordinate, I guess, if we're working with, 90 degrees? So here's the point that is on the unit circle that corresponds for the angle, 90 degrees. So do you remember the coordinates here? 0, 1. And we just need the y-coordinate, which is 1. And I guess over here, not that we need to really know x, who cares, but x was 0, y is 1, r is 1, but we just needed to plug in for y and r. Final answer, 1. So if you need to find the sine of an angle, of like a specific angle, like 90 degrees or 180 degrees or whatever, you just need to get those coordinates that are on the unit circle radius 1. Now some notes. Again, you're going to probably need to pause the video here after I reveal all the blocks, and you're going to probably need to pause because I'm going to be moving right along. But I've already said this, haven't I? Well, we're just going to put them into like identity form, I guess, because these are official trig identities, and they're called the reciprocal identities, shockingly enough. And the sine of theta would be equal to 1 over what? What is the function, what is the other function out of the other 5 that the sine is the reciprocal of? Cosecant. And cosine would be equal to 1 over secant, like I've already sort of said, and the tangent would be equal to 1 over cotangent. And then it's kind of getting repetitive here, I guess, but cotangent's 1 over tangent, secant's 1 over cosine, cosecant is 1 over sine. So you're going to need to pause the video, and if you need time to write those down. Same thing here with, pausing the video to give yourself a chance to write everything down, but these are called the quotient identities. I wonder why they're called the quotient identities. Because they involve a quotient. So, anyway, they just say that the tangent of theta is equal to sine of theta divided by the cosine of theta. So this is just a true statement. Okay? This and this are the same. And can you figure out what the cotangent of theta would equal? Think about it. If tangent and cotangent are reciprocals of each other, then wouldn't that make it cosine over sine. Okay? And these are the three what we call Pythagorean identities. And if you're thinking to yourself, I wonder if this has anything to do with the Pythagorean theorem. Yeah, it does. Okay? In a not so obvious way right now. It's really not kind of clear. But they do, you know, they're not called the Pythagorean identities for no reason, okay? But as you're writing these down, and before I move on, I will, I guess, quickly point out that this purple one, sine squared of theta plus cosine squared of theta equals 1, that's, in a way, the most important one, and you're going to use it more and stuff. And I guess for certain reasons and whatever, that would be the more, I don't know, important quotient identity. Maybe I'll also say this. I mean, it's not that tough to see how this identity follows from this identity. You know, we already kind of talked about it. The fact that sine squared of theta plus cosine squared of theta equals 1, these other two, you can definitely say sort of follow from this one, right? Like these are true because that's true in a way. I'm struggling to kind of say it in the best way, but right now. But these two just sort of like follow suit and just kind of derive from this purple one. Anyway, let's move on. Spend enough time there. Oh, and we find ourselves at the end of the notes here. The final example problem, or two. Okay? Last couple examples. The first one says, given the sine of theta is 2/3, and the cosine of theta is root 5 over 3, find the value of each of the four remaining. Well, the four remaining would be tangent, cotangent, secant, and cosecant. Okay? So if we know what sine is and what cosine is, how can we figure out tangent? Well, remember the quotient identity, that the tangent is equal to sine over cosine? Well, we know sine of theta is 2/3 and cosine of theta is root 5 over 3. And so it's 2/3 divided by root 5 over 3. How do we do that? How do we divide by a fraction or divide using fractions? We multiply by the reciprocal. And anything going to cancel here, you know, before, like, if I haven't said this in class already or made it clear in class, I like to simplify and cancel things before, like when I'm multiplying two fractions together, even before I multiply across, I like to see if anything can cancel. Here, the 3's can cancel with each other, and we're going to get 2 over root 5 as my final answer for tangent of theta, which, again, I don't make you fix that. We could totally rationalize that denominator by multiplying top and bottom by root 5, but no need. And for the final 3, you know, if we know sine and cosine and tangent, why can't we just take the correct ones and flip them to get the corresponding ones, right? So which one do we flip for cotangent? We flip tangent. Bam. Which one do we flip for secant? We flip cosine, which we were given in the first place. 3 over root 5. And I guess process of elimination, which one do we flip? Well, not just process of elimination. You should know this, right, by heart. Which one do we flip for cosecant? We flip sine, which we were given in the beginning as 2/3. So when we flip it, we get 3/2. Moving on to the final example, given that the sine of theta is 1/2 and that 0 is less than or equal to theta, which is less than or equal to pi over 2, find the value of cosine using a trig identity. So if you are given sine, how do we figure out cosine? By using that Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. So this is where that can come in handy. So the sine of theta, and I don't know, like, okay, quick, like, let's slow down for a second, kind of a timeout or whatever, like, kind of a side note, right? Because I don't know if I've mentioned this in class yet, so I better say it now, because I probably should have said it here. But the sine squared of theta simply means the sine of theta squared. In other words, you could write it in a different way, like this. Like this is what sine squared of theta means. You know, it's the entire sine of theta squared. It's just, I don't know, maybe someone at some point decided this was a cooler way to write it, a little less messy. It saves you the trouble of writing parentheses all the time and whatever. So, but when you see sine squared of theta or cosine squared of theta, it's just that entire trig expression, that entire trig thing squared, okay? So, if the sine of theta is 2/3, then this just means, oops, sorry. I shouldn't have went up here because we're down here now. So if the sine of theta is 1/2, then sine squared of theta is just 1/2 squared. And we don't know what cosine is yet, but we will. But we're basically from here on out, we're going to solve for cosine. So 1/2 squared, flashback reminder, to square a fraction, you square both numerator and denominator, and that's how we get 1/4. And we're going to continue to solve for cosine of theta, so let's subtract 1/4 from both sides. So again, we are subtracting 1/4 from both sides of the equation. You know, we've gotten cosine squared by itself of theta, but we want to know what the cosine of theta is. So, cosine squared of theta equals 3/4. How do we take that and figure out or end up with it just saying cosine of theta? How do we make cosine squared of theta into just cosine of theta? Well, by taking the square root of both sides. Okay? So what's the square root of 3/4? Now remember, this is how square roots work. You know, if you take the square root of a fraction, you can break it up into a separate numerator and denominator. We can't really take a clean square root of 3, but we can take a clean square root of 4. And so we get a final answer. Let's get the, oops. Hey. Anyway, as I was saying, we get a final answer of root 3/2. Now, just kind of planting some seeds for the future really quick before we stop. What was this all about? Well, how much do I want to say right now? Well, I don't know. I guess, well, I'll at least say this. When you take the square root of both sides of an equation, like, you know, remember doing things like, don't write this down, but, you know, if you were going to solve something like x squared equals 25, and you were going to be taking the square root of both sides, don't you get at the end 2 answers, which are plus or minus 5? You know, positive 5, negative 5. You get 2 answers. Well, guess what? Technically, here, you should get 2 answers. Positive root 3/2, and also negative root 3/2. But I'll just say this for now. Considering the extra rules that were stated here, the extra stipulation, and how theta needed to be between 0 and pi/2, or 90 degrees in other words, we go with the positive answer. So I'll leave it at that for now.